Hi, my name is Athena Tran, and today I will be talking to you about carburetors. Although it is not commonly found in cars today, the carburetor was essential to car engines when they were first produced. Today, we can still find them in machines with smaller engines, such as lawnmowers. So what is a carburetor? Essentially, it is a part that will help optimize engine performance by ensuring enough air is mixed with gasoline so that all of the gas will burn during combustion. If not enough air is provided, the engine will run rich, often resulting in poor fuel efficiency and the possibility of black smoke being produced. If there is too much air mixed with the fuel, the engine runs lean, producing less power and more heat. Despite all of its fancy parts, a carburetor is essentially just a tube through which filtered air flows from the machine's air intake. Within this tube, there is a narrow opening called the venturi, where a vacuum is created. The float chamber provides fuel to the narrow opening via a small hole called a jet. The float chamber is a container filled with an amount of fuel. The vacuum created in the venturi draws in fuel from the float chamber, which is at a set pressure. Bernoulli's principle is essential to understanding the carburetor. The principle proves that when the velocity of a fluid increases, there must be a decrease in pressure. P1, ρ1, and V1 are the static pressure, density, and velocity, respectively, at point 1. P2, ρ2, and V2 are the static pressure, density, and velocity at another location in the flow. We can assume that the density of the fluid is approximately constant, so ρ1 is about the same as ρ2. If at some point 2 the fluid velocity increases, this will result in V2 being greater than V1. For each side of the Bernoulli equation to remain equivalent, P1 must be greater than P2. Therefore, the high velocity at the narrowing yields low pressure. In application to the carburetor, the faster the filtered air comes in through the carburetor throat, the lower the pressure in the venturi. This results in a higher pressure difference between the venturi and the float chamber, and more fuel flows out of the jet and mixes with the airstream. As the throttle opens, more air is drawn into the engine, bringing with it more fuel, which makes the engine create more power. Issues with the use of the carburetor in a larger engine is the need for the throttle to be open for the engine to be able to use fuel. When idling, the throttle is closed, but an idle jet is needed to allow a small amount of fuel to enter the engine to prevent it from stalling. This results in the possibility for excess fuel vapor to escape float chambers, which is ultimately bad for the environment and efficiency of the engine.